Hi and welcome back to another AP Calculus video. Today we're going to be talking about the average value of a function. And here's a scenario just to kind of set this up and give you an idea of when we might be asked this question. Suppose that I have an equation representing the velocity of an object. And I want to know over a period of time, what's the average velocity? Well, really what we would do is, in a perfect or in a data-driven scenario, we'd take a bunch of data points and we'd average the velocity up together, and that would be that in my mind, that's kind of how you would power your way through finding that average velocity. But there's a little bit more of an elegant way to go about it. So remember that average velocity, and we're going to come back to this information here. So let's recall that average velocity is simply the change in position over the change in time, right? So the instantaneous velocity is the derivative of your position at whatever the instant is. So that's the idea, that's the difference between instantaneous velocity. Instantaneous velocity is just the derivative of the position at a specific instant. It's like, hey, I just took a snapshot, or I shot you with my radar gun, you were going 65 miles per hour. Boom, instantaneous velocity at that instant. The average velocity takes an interval and it says, okay, I'm going to find the change in position over the change in time. And we learned about this when we dealt with this thing called the mean value theorem that says, hey, on a closed interval where we're continuous and we're differentiable, there's going to be somewhere on that interval where the average velocity is going to equal the instantaneous velocity. And you're guaranteed to have a spot where that happens. That's what the mean value theorem says. But here today, what I want to focus on is this average velocity. So to find the average of v of t, we find our change in position. Well, that's s. And let's continue with our b and our a. So this is our interval a to b over b minus a. Well, we've been learning about this thing called an integral. And yesterday, I keep saying yesterday, in the previous video, we learned that this s of b minus s of a is also equal to this integral. We talked about this thing called the definite integral. So to find the definite integral, we had to find the antiderivative and subtract at b minus a. S of b minus s of a, that's my displacement. So if I want to find the average velocity, rather than going through the trouble of, or sometimes I would have to go through the trouble of finding the antiderivative, what I want to understand is that the average velocity can be found by doing the definite integral of the velocity, because that's s of b minus a, that's your displacement, over b minus a. So really, this is your average velocity, and to find the average velocity, you're just going to integrate the average velocity over the interval and then divide it by the change in time. Now, I want to talk a little bit about another reason why we would need to divide by this change in time, but this right here is really related to everything we've been doing. Now, your book is going to rewrite it like this and say, we're going to bring that 1 over b minus a to the front and write it like this. But essentially, it's the same thing. Okay, we just wrote it a little bit differently. It's an equivalent form. Now, remember though, here's another reason why we divide by this b minus a. If we are given the velocity and we want the average velocity, when we integrate velocity, say that velocity is miles per hour, our resulting units are going to be miles. In order to turn it back into a velocity, we need to divide it by a change in time and turn it back into miles divided by hours, or miles per hour. This concept is going to be handy to think about when we consider functions other than velocity. So suppose we're given a function that represents a rate at which water is flowing in a pipe in gallons per hour. The rate varies throughout the day. We want to know the average rate at which the water is flowing during the first 4 hours. Write an integral expression to represent the situation. This is a really great example of the type of problem that the AP exam might ask you to do. Instead of evaluating an integral, we just need to write one, okay? And we can get points for this. So let's think about units. G of t is measured in gallons per hour. So if I want the average rate, what I'm going to do is I'm going to find the change in the gallons over that period. So from 0 to 4, I'm going to find the gallons at time 4 minus the gallons at time 0. That gives me how many additional gallons have flowed into this tank. And then I'm going to divide it by the amount of time, 4 minus 0. It's slope. That's all it is. It's the average rate of change. It's the average rate of the amount of change of the amount of gallons in this tank. Now, this gallons at 4 minus gallons of 0, let's think about this in terms of units and integrals. If g of t, lowercase g of t, is the rate, gallons per hour, then to find the number of gallons, I'm not going to go through this trouble. I am going to write it as an integral. This integral right here represents what I would get when I say gallons at 4 minus gallons of 0. I would get gallons. I'd get the amount of gallons that have changed from time 0 to time 4. So these will become gallons. And specifically, it's the change in gallons over those 4 hours. How many gallons have you added to the tank? So to find the average rate of change, we need to turn this back into gallons per hour. So we need to divide by time, right? And if 4 hours have elapsed, then we're going to take this integral, which is gallons, and we're going to divide it by 4 hours, which is the 4 minus 0. This is the change in time. And we get this integral. By dividing by time, you're taking your gallons per hour, turning it into gallons, and then back into gallons per hour by multiplying by 1/4 or dividing by 4, however you want to think about it. So this is the average rate of gallons of water flow, I guess would be the better way to say it. The average rate of water flow over 4 hours. And then if you had an equation, you could find the actual numerical answer. So all this to say that we have this equation, whether you like the way we thought about it with velocity and displacement, or whether you like the way we think about it with units, considering those ending units, this is how we're going to find the average velocity or the average of a function. And the way that I kind of really make sure we understand this is that the average of the function is the function we're given. It's the function in the integral. So those are the same functions. It would be different if I was given position and asked to find the average velocity. Then I'd just use the slope formula. So two different functions, use slope. If you want the average of the function in the integral, this is the formula that you're going to use. So let's use it. Let's find the average value of some functions, and we'll kind of see that it's pretty easy. The tricky part about this is knowing when to use it and when to apply it. So find the average value of the following functions. So I am going to write the equation first. So it's going to be, this is a and this is b, so 1 over b minus a, so that's 3 minus 0, and then I'm going to integrate from 0 to 3, and then my equation, 4 minus x squared dx. So again, this is the equation that I'm using up here at the top, and I'm just plugging the numbers in. So now I'm going to have 1/3, and now I'm going to use my antiderivative, so 4x minus x cubed over 3, turn it into box notation, put the 0 and the 3 on the edge of the box. So I'm going to have 1/3, and then when I plug in 3, I feel like I've done this problem before. 4 times 3 is 12. 12 minus 9 is 3. Minus, and when I plug in 0, I get 0. So 3 minus 0 is 3, so 1/3 times 3 is 1. So the average value of this function on that interval is 1. Okay. Let's try this next one. So we want to find the average value of 3 cosine x squared minus 5. Well, you know what? This one's kind of ugly. So here's what I'm going to do. I'm going to set this up. I'm going to say 1 over b minus a, so 3 pi over 4 minus 0. And then the integral that I'm going to set up is this. Okay. 3 cosine x squared minus 5 dx. Now that's my integral. And you know what, you guys? This one, we actually don't know how to integrate anything like this yet, and that's okay. So here's what we're going to do. We're going to use our calculator. And a lot of times these types of problems will show up on your calculator, and hopefully we're getting proficient at using our calculators to evaluate these mathematical things. And we want to be really comfortable with it. So here we go. I'm going to hit Math 9. Make it so we can all see what's happening. Math 9. I'm going to type in 0 to 3 pi over 4. And then I'm going to type in my equation, 3 cosine x squared minus 5. dx. Double check that I did everything right. Now here's the deal, you guys. When you are evaluating these and when you are using your calculator to evaluate an integral, you have to write it down on the paper. So like what I've shown here, you would need to write all of this, whether it's on a test or on your AP exam. Then you could punch it into your calculator and write a number down. So this is my integral. This is what the integral turns out to be. But then I'm going to multiply it. This 1 over 3 pi over 4 actually turns into 4 over 3 pi. So I'm going to take my decimal, that negative 0.9, whatever it was. I can't get it to stand. 987,025. Dot, dot, dot. If you're going to hand key decimals, always go to 6 places if you need to use them. But I'm going to go ahead and just multiply by 4. And then divide by parentheses. You got to put anytime it's more than just one number that you're dividing by, you have to put it in parentheses. 3 pi. So negative 0.419. We need to get comfortable using our calculator, and I will specify for you right now which ones you should use a calculator on and which ones you should not. I wanted to put this one in here because this was a great calculator practice. In the future, there will be less and less that you'll use your calculator for in terms of using your integral and evaluating it. But for now, we need to get comfortable with that so that on the calculator portions of our test, we go right to that calculator and we don't waste time trying to find an antiderivative. If you have a calculator available, use it for the integral. Do not find the antiderivative. It takes too long, and sometimes you can't. Okay? But we're going to end with this, and it's the mean value theorem for definite integrals, and it says this: a continuous function on a closed interval always assumes its average value at least once in the interval. So if we go back up here and look at these functions, where do they assume their average value? Well, if the average value here in number 1, and we'll just kind of finish, we'll just do this with number 1. If the average value is 1, like we found here, then where does f of x equal 4 minus x squared equal 1? Where does that happen? Well, we would just solve it, right? So add x squared over minus 1, we get 3 equals x squared. So x equals plus or minus the square root of 3. It's the same as when we found and solved for c using the mean value theorem in chapter 4. But we get plus or minus square root of 3. We check the interval. We're going to throw out the negative. So only x equals square root of 3 because it has to be within that interval 0 to 3. So it's the same idea. Where does it assume that value? Where is f of x equal to 1? You have to solve for the value of x. So at square root of 3, we assume that average value. The second function would also assume its average value somewhere. We're just not going to take the time to do that. But this would be a reasonable question for you to answer. So again, we're using antiderivatives. We're finding the average value, just utilizing this function. It's not too terribly difficult to use. Again, the tricky part is knowing when to use it in the midst of the word problems. And so as we start seeing AP exam questions, we'll see that it is tricky to know when to use what rules. But for now, keep practicing, keep studying. You can do this. Don't worry about not mastering something right away. Very few students are 100% proficient. And as a matter of fact, I can probably count them all on one hand in my experience who have mastered everything at the first try. So do not fear. You're going to get it. It's going to be okay. You can do this. You've got this.